Okay, with systems of equations, it means you have two or more linear equations on one graph. And to find the solution, you have to find where they intersect each other so that you can write your answer as an x and a y. So you may need to pause this to write this down on your notes. Okay, so we're going to have two equations, and we're going to find the intersection point, and that'll be our answer. Okay, so we have three types of answers. That if they're intersecting lines, there'll be exactly one solution. If you have parallel lines, there's no solutions. And then if you have identical lines, in other words, the same line on top of each other, we have an infinite number of solutions. Oops, I misspelled that. Okay. A lot of times the no solutions will look like, this, and an infinite number of solutions will look like that for our notations. Okay, the first thing we need to make sure of is that our equations are in slope-intercept form, which is y equals mx plus b, which is slope-intercept. Okay, slope-intercept form. So if I look at the first one, this has y equals, and there's an understood 1 in front of that, x minus 8. This is written in the correct form. So for the first equation, I'm going to say my slope is 1. I'm going to put it 1 over 1, because slope has to be a fraction. And then remember, the constant that's by itself is our y-intercept, so I'm going to write that as a point, and that'll be my first line that I draw on my graph. So 0, negative 1, 6, 7, 8, I'm sorry, 0, negative 8 is down here, and then remember your slope is your rise over your run, so that means from here I'm going to go up 1 and right 1 and continue that pattern all the way to the right, and then I need a straight edge to draw my line, which I'm running short on those, so I'll use this paper. Okay, so there's my first line. I'm going to draw it all the way through because my lines have to intersect. Okay, so if I change colors here for my second line, I'll go with this purple. The second equation has y equals negative 2x plus 1. My slope is with the x, so that means it's negative 2, and I'm going to put it over 1 to make it a fraction. And then the plus 1 is my y-intercept, so I'm going to write 0, 1. If I plot this point right there on the 1 on the y-axis, the slope, remember this is my rise over my run, so I'm going to go down 2 because it's negative, and write 1. Down 2 and write 1. And there's my intersection. I'm going to draw my line. Put arrows on the ends because these are continuous lines. And now my solution is right here where they intersect each other. And the coordinates looks like 3. And it went down 5, so it would be 3, negative 5 is your solution. Okay, if I go to number 2, I'll look at the first one, and the y is by itself, so this is written in slope-intercept form. So for the first equation, I know my slope is 1/2 because it's always with my x, and then the plus 9 represents my y-intercept. So I'm going to plot that point first. And then my slope tells me my rise over my run, so I'm going to go down 1 and right 2. Okay. My second equation has a negative x, there's a negative 1 understood in front of that x, so that means the slope is a negative 1, and I need to make it a fraction, so put it over 1. Then a plus 6 is my y-intercept, so I put 0 and 6, and I need to plot this graph. Oh, I just realized I graphed the first one wrong. I just now realized. Let me see, where'd my orange pen go? Okay. I went down 1 and right 2. I was supposed to go up 1 and right 2. So this graph should be going actually in this direction. Let me get some white out and I'll get rid of the other one. Okay, so let me get my graph going the right way. Alright, I'm going to pause and get some white out and get rid of that one. Okay, there's my tacky white out now. But now I have my line going in the right direction, so that now I can graph the second one. It starts at 0, 6. And for this one it goes down 1 and right 1. Or the other direction would be left and up, so I can see where it intersects each other. In that particular fashion. And now my lines intersect where I can see their intersection point. Looks like it's negative 2. 1, 2, 3, 4, 5, 6, 7, 8. Looks like it's negative 2, 8 for my intersection point. Okay, sorry about that. Alright, on the back of your page, we have a couple more examples. But these are not necessarily written in a nice, neat order. If I look at number 3, this is not written in slope-intercept form, so I've got a little bit of work to do first. So for the first equation, what I have to do is I have to move the 3x to the other side, so that means I'm going to add 3x. Which means I have y equals, and I'm going to put that 3x first so I'll have it in the right form. The 8 comes down behind it, it's a positive 8, so I put a plus sign. Now this is written in the correct form. My slope is 3 over 1, and my intercept is 0, 8. If I plot 0, 8 and then go up 3 and over 1, I'm off my grid, so I'm going to go the opposite direction. 3, back 1, 2, 3, back 1, 2, 3. So I have my line. Okay. Now my second equation is not written in the correct form either. I have negative x plus y is equal to negative 2, so I put a 1 in front of that x, and when I move it, it changes to a positive 1x. So I have y equals 1x minus 2. My slope is a 1 over 1, and my intercept is 0, negative 2. If I plot my point, on my graph, it appears to be an estimate on this one because my graph is not quite right. 2, 3, 1, 2, 3. Looks like it should have been right there. My orange line got off. Looks like it should have actually been right there at that intersection. So I was following the slope to see where they actually intersected each other. So this appears to be at 1, 2, 3, 4, 5. It went left, so that's negative 5. And 1, 2, 3, 4, 5, 6, 7. It went down 7. So it appears that my solution is negative 5, negative 7. Okay. On number 4, the first equation, x plus 2y equals 4, is not written in the correct order. So I'm going to bring it down here so I can manipulate it. I notice the x has got to go to the right side, so I'm going to subtract the 1x. That gives me 2y is equal to negative 1x plus 4, but the y is still not by itself, so now I have to divide by 2, and that gives me y is equal to, here's my slope, negative 1 over 2x, and then 4 divided by 2 is a positive 2. So my slope is negative 1/2, and my starting point, which is my y-intercept, is 0, 2. Alright, this is negative 1 over 2, so that means I go down 1 and right 2. Okay, I want to draw my line. Okay. The second equation is already written in the correct form, if you look at that. So my slope is negative 1/2, and this one starts at 0, positive 2. So 0, 2 is the same starting point as the other one, and the slope is identical. So my lines are on top of each other. Okay, they're right there on top of each other. And when that happens, they're identical lines. That means there's an infinite number of solution, which looks like this, the infinity symbol. So you can either write the word or you can write the symbol to represent the number of answers. Okay. Alright, number 5, we have the first equation that has x plus 3y equals negative 15. I'm going to put a 1 in front of that x, and I have to get it in slope-intercept form, which is y by itself. I'm going to subtract the 1x from each side. That gives you 3y is equal to negative 1x minus 15. I now have to divide everything by 3, so that the y is by itself. I'll have negative 1/3 x for my slope, and then negative 15 divided by 3 is a negative 5. If I identify my two important aspects, I have my slope is negative 1/3, and my y-intercept is 0, negative 5. I plotted my y-intercept, and now go down 1 and right 3. 3. Right there represents my equation. And now if I look at my second equation, this is one of those interesting ones where I don't have an x available, which means I'm either going to have a horizontal or vertical line. Well, if there's not an x, that means the x is a 0, which means the slope is 0. This represents your y-intercept. So I want to go down to 0, negative 7. Oh, 7. 1, 2, 3, 4, 5, 6, 7, right here. And since it does not contain the x is 0, that means I cannot go up towards the x-axis at all. That means this is a horizontal line going through my graph. It's horizontal. It does not contain the x, so it must not cross the x-axis. There's our intersection point. Looks like it's a 6, and then it goes down 1, 2, 3, 6, 7. Looks like it went down negative 7, and that would be your solution. Okay, Okay. Number 6. The first equation is given to you in slope-intercept form, so I need to identify the slope, which is an understood 1 in front of that x, so that means your slope is 1 over 1, and your intercept is 0, 5. Okay. The second equation is not written in the correct form, so I'm going to rewrite it here. I'm going to put a 1 in front of that x and subtract it and move it to the other side. So I have actually a negative y drops down. I have a negative 1x plus 2. Now this negative y, I'm going to put an understood 1 in front of it, so that now I divide by that negative 1. And that gives me y equals, negative 1 divided by negative 1 is just a 1. And 2 divided by negative 1 is a negative 2. So my slope is 1 over 1. And my intercept this time is 0, negative 2. And now, if I look at my lines, I notice that they're not going to intersect. Okay? And if I also notice, the slopes are identical. They're the same. So if I have parallel lines will never intersect each other, so therefore there is no solution for parallel lines. Now you can either write the words no solution, or you can write the symbol that is that line through it, 0 with a line through it. Alright, number 7, we have a lot of work to do because neither equation is written in the correct form. So if I take the first equation, I have 3x minus 5y equals negative 35. I'm going to move the 3x to the other side of my equation, and negative 5y drops down so that I have negative 3x minus 35 on the right hand side. But I have to divide everything by negative 5 now. So that I have negative 3 divided by negative 5, the negatives cancel out, and I'm going to leave it 3 over 5x. The negative 35 over negative 5 divides and gives you a positive 7. So my slope is 3 over 5, but my intercept is 0, positive 7. Excuse me. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go up 3. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5, and 1, 2, 3. Okay, I did as many steps as I could so I could see where my line is. Okay. My second equation is not written in the correct form either, but it is less steps than that first one, because the only thing I have to do is move the 2 to the other side of my equation, becoming a negative 2, which will give me y equals negative 2x minus 6. So my slope is with my x, so my slope is negative 2 over 1, and my y-intercept is 0, negative 6. Plot your intercept. And now this tells me negative 2. That means go down 2 and right 1. My line's the other direction, so I'm going to go left 1 and up 2. so I can trace it back to where it appears to cross. And there it is. Draw my lines so that I can see these are intersecting lines. So I have one solution. And that solution is right there, which is 1, 2, 3, 4, 5 to the left, so that's negative 5. And then it's 1, 2, 3, 4 up, so that's a positive 4, and there's my solution. Okay, and last one. Number 8. The first equation is given to us, and it's kind of strange, x equals negative 2. But this reflects back to number 5, where I had y equals negative 7. With the y, I went on the y-axis and plotted negative 7. And then I drew my line so that it did not touch the x because I did not have an x available. So I'm going to do the reversal here. This says x is negative 2, so on the x-axis at negative 2, I'm going to put a dot. This does not contain the y values at all, so I cannot touch the y-axis. That means this is going to be a vertical line at x equals negative 2. It means it has an undefined slope. Cannot touch the y. The second equation, I've got a lot to do because this one's written in standard form. So when I write it, I have to first move the x by subtracting 3x, and that means the negative 2y drops down. I'm going to write the x first, but then I have to divide everything by negative 2, and my new equation is y equals 3 over 2x, because the negatives cancel out, and then negative 18 divided by negative 2 is a positive 9. My slope is 3 over 2, and my y-intercept is 0, 9. So way up here at the top is where my starting point is. Now it tells me to go up 3 and over 2, so it's somewhere over there, but so I'm going to go backwards. I'll go back 2 and 1, 2, 3. There's my intersection point. 2, 3, kind of like that. I don't like using the dot that's off my grid because your line can sway. Alright, so there is my intersection point. These are intersecting lines. So it looks like it's at negative 2, but it's up. 1, 2, 3, 4, 5, 6 is my solution. Alright, that is how you graph the method.